Example 32. Secant of x times cosine of x. Let's change secant of x to its reciprocal identity here. Okay, so now we have 1 over cosine of x times cosine of x, which would be cosine of x over cosine of x, and anything divided by itself is 1. Cotangent of x times sine of x. Usually if you see cotangent or tangent, it's going to help you to switch it to one of its quotient identities. Cotangent of x is the same thing as cosine over sine. I'm going to keep that sine of x alone. And then if we were to multiply these together, your sines would cancel one another out, leaving you with cosine of x. Final answer. 34, tangent squared of x minus secant squared of x. Now, notice that kind of somewhat matches this Pythagorean identity here. But this identity here, notice secant is positive, tangent is negative. And when that's the case, your answer is 1. Well, over here, it's the reverse. Tangent is positive, secant is negative. Therefore, it's not going to be 1, but -1 as a final answer. That's your answer for 34, -1. For 35, this parenthesis here has 1 minus cosine squared of x. If you'll notice right here, 1 minus cosine squared of x is the exact same thing as sine squared of x. So I'm going to substitute that. Now, cosecant of x, that's the same thing as 1 over sine. So I will change that. Now, if I multiply these two together, we would have which simplifies to sine of x. Final answer. Example 36, we have secant squared of x minus 1. If you look right here, this is where secant squared of x minus 1 is. That's the exact same thing as tangent squared of x. So I'm going to rewrite that. Rewrite this as tangent squared of x over tangent of x, which reduces to tangent of x. 37, cosecant of x times cosine of x. Let's change this to its reciprocal identity, which is right here, 1 over sine of x. If we multiply these two terms together, we would get cosine over sine. And as you can see right here, that's the quotient identity. Cosine over sine is the exact same thing as cotangent. Cotangent of x. Final answer. For example 38, they want you to determine the period. Here our period is x over 2, or 1/2. And in order to find a new period, that formula was 2 pi over b. Here our b value is 1/2. Now, if we were to flip, we would keep 2 pi as 2 pi, change from division to multiplication, and flip 1/2 to 2 over 1, or simply 2. So your period here is going to be 4 pi. 39, it wants us to determine the amplitude. In order to do that, you take the absolute value of that number that is in front of your trig function. So the absolute value of -5 is +5. So that's your amplitude. For 40, determine the period. Our B value here is 4. Our final answer of pi/2. They want you to find the value of cosine of 5 pi/3. So what you want to do is you want to go to where 5 pi/3 radians is, which is right there, and locate the cosine value, which is 1/2. That's your answer, 1/2. That's it. Example 42. I want you to find the value of tangent of 7 pi/4. So you'd want to locate where is 7 pi/4 in the unit circle, which will be here. That tangent C is -1. That's your answer, -1. For example 43, find the value of secant of pi/2. Pi/2 is here. Now the reciprocal of secant is cosine, and the reciprocal of 0 in these scenarios is going to be undefined. So that would be your answer there. For 44, let's change cosecant to its reciprocal identity here. So change that to 1/sine. Tangent, let's change that to its quotient, which is sine/cosine. Now here your sine values would cancel one another out, leaving you with 1/cosine of x, which reciprocal identity of that would be secant. (45) Now tangent times cotangent, those are reciprocals of one another, so they're going to cancel one another out. But when they cancel one another out, that leaves you with the value of 1 minus cosine squared of x, and 1 minus cosine squared of x is equal to sine squared of x. (46) Okay, secant, let's change that to its reciprocal identity, which is right there. And change cotangent to its quotient. And 1/sine of x is the same thing as cosecant. I'm going to change tangent to its quotient. Cosecant to its reciprocal identity. And I'm going to leave cosine alone. Okay, looks like our sines will cancel one another out. Now, if I just multiplied these two together right here, that would leave me with 1/cosine of x. Now those cancel one another out, leaving you with 1. 48 sine squared of x plus cosine squared of x. See that right here? That's equal to 1. So that numerator simplifies to 1. And 1 over sine of x, its reciprocal identity is cosecant. One minus a sine squared of x, same thing as cosine squared of x. One minus cosine squared of x, same thing as sine squared of x. And what we now have is a quotient identity. Cosine of x over sine of x is cotangent, but since we have cosine squared over sine squared, then it would be cotangent squared of x. All right, sine of x over tangent of x. I'm going to leave sine of x alone. But I'm going to change tangent of x to its quotient. Now this is the same thing as sine of x divided by sine of cosine. And now you're going to want to do keep, change, flip. Okay, let's change cosecant to its reciprocal identity. And secant to its reciprocal identity. Now I'm going to keep 1 over sine of x, change from division to multiplication, and flip 1 over cosine to cosine over 1, and then multiply. And now we have the quotient identity of cotangent. One minus the sine squared of x. That's the same thing as cosine squared of x. And it looks like once again we have quotient identity. All right, for 53, 1 plus tangent squared of x. It's right here. Over 1 plus cotangent squared of x. Right there. Okay, now secant squared of x. That's the same thing as 1 over cosine, but since it's squared, make sure you square the cosine. Divided by over cosecant squared of x, same thing as 1 over sine squared of x. Now go ahead and do keep, change, flip. If you multiply this out, and then here you have the quotient identity. Here, just now realizing I wrote the wrong letter. That should be a T, not an S. Cotangent squared of x. One minus cosine squared of x. Same as that. Right here, that's what 1 minus sine squared of x is equal to. Anything divided by itself is 1. Example 76. In order to begin solving this one, you're first going to want to add root 3 to both sides.
Okay, yeah, those big tough, but happy.
Then divide by 2. And from here, all we're trying to do is figure out where in our unit circle is our sine value, root 3 over 2. Well, that would be here at pi over 3 radians. And then again, right there at 2 pi over 3 radians. Start example 77 by setting the equation equal to 0. Subtract both sides by tangent of x. Now we have two terms that both have tangent in them, so we can factor out a tangent. And now set both of these factors equal to 0 and then solve further if needed. Okay, here, tangent of x is 0. Where in the unit circle do we have a tangency of 0? That would be here and here. It's going to be at 0 radians and pi radians. Over here, we would have to add 1. The reciprocal of secant is cosine. And the reciprocal of 1 is still 1. So where in the unit circle do we have a cosine value of 1? Here, that's at 0 radians. So odds are your final answers are going to be 0 and pi, because that's the same answer as 1. Start example 78 by adding 1 to both sides. Then square rooting. So where in the unit circle do we have a tangency of 1 and negative 1? That would be here at pi over 4. And then again at 3 pi over 4. There at 5 pi over 4. And then right there at 7 pi over 4. Okay, 79, add root 2, then divide by 2. So where in the unit circle do we have a sign value of root 2 over 2, positive root 2 over 2? That would be here at pi over 4 radians. And again here at 3 pi over 4. To begin by factoring out a tangent of x. Oops. We have to solve that one a little bit further. You're going to need to add 1 and then divide by root 2. And remember, we have to now rationalize that the denominator cannot have a square root on the bottom of the fraction. 1 times root 2 over root 2 times root 2. So where in the unit circle do we have a tangency of 0? That's going to be at 0 radians and pi radians. And then where in the unit circle do we have a cosine value of positive root 2 over 2? Here at pi over 4. And then again here at 7 pi over 4. Start this one by setting the equation equal to 0. And then factor out a cosine. Then set both those factors equal to 0 and solve. This one we would need to add 1 and divide by 2. So looking at this one here, where in the unit circle do we have a cosine value of 0? That would be here and there. So that's at pi over 2 and 3 pi over 2. Where in the unit circle do we have a cosine value of positive 1/2? There at pi over 3 radians. And then again here at 5 pi over 3. Okay, you want to solve 82 in almost the same fashion as you would this trinomial here. We need the factors of 2 times 2 that add to get 5. So where in the unit circle do we have a cosine value of 2? We don't. Don't worry about that one. But where in the unit circle do we have a cosine value of positive 1/2? Here at pi over 3. And then again here at 5 pi over 3. Okay, we want to solve this one in a similar fashion as this trinomial here. We need the factors of 1 times -6. Let's subtract to get -1. Where in our unit circle is sine -2? Doesn't exist. Where in a unit circle is sine 3? Doesn't exist. No answer here. All right, start this one off by dividing by 4. Then square root. Square root of 1 over the square root of 4. So where in the unit circle do we have a sine value of positive 1/2 and negative 1/2? We're going to have 4 answers for this one. Two times 1. Where in the unit circle is sine -1? Right there. And where is sine -1/2? There. And there. Start by factoring in a cosecant. Solve this one a little bit further. Okay, now the reciprocal of cosecant is sine. And the reciprocal of -2 over √3 is -√2.
√3/2.
So where in the unit circle is sine negative √3/2? Here. And there. Okay, start this one by adding 1 and then dividing by 2. Okay, now let's first figure out where is our sine value 1/2. There at pi/6. And again here at 5/6. Now that we've established that, we're going to set both of these answers equal to 2x. In order to solve for x, multiply by the reciprocal. So these would be answers. 4 times 1.
Or wasn't that girl?
No, 2 times -2. Reciprocal of secant would be cosine. Reciprocal of 2. Now we don't have a cosine value of -2 in our unit circle, so this is the only one you have to solve for.